Hey guys, how's it going? My name is Gabe and this is Games with Gabe, and this is the next episode in the Coding a 2D Game Engine in Java series. In the last episode, what we got to was where we basically have Mario in here, and if we go and run around with him, we can sort of run, and he switches his animations based on what we're doing, which is all good. In this episode, what we're going to do is we're going to implement jumping and hopefully start on some enemy AI. So basically, we're going to implement it so that when we press spacebar or up, Mario jumps, and it's going to be a variable length jump. So in order to do this, the first thing we're going to have to do is create a way to check and see if Mario's on the ground. So let's go ahead and figure out how to do that. But before we do, very quickly, we have this annoying debug message, which was useful at the time, but we don't really need this. So let's just go into state machine, and we're going to get rid of this little warning because we don't really need that. And then we can go back into player controller, and we're going to be spending most of our time in here today. So let's go ahead, and the basic way we're going to check and see if Mario is on the ground is basically if we have like our player right here and we have a bunch of ground, we're just going to shoot a couple of raycasts from the left side of the player and the right side of the player, see if it hits the ground. If either one of them does, then we're going to return true. Otherwise, we're going to say we are not on the ground. So we're going to create a function, just call this public void check on ground. We're going to be reusing this quite a bit throughout other ones, so we may abstract this into its own utility type function, which we might or might not do in a little bit. So then we're going to have a vector 2f raycast begin, which is just a new vector 2f. This.gameObject.transform.position. So this is where the raycast is going to start, and we're going to say float inner player width. So this is going to be like a width of the player that's small enough to just barely reach the left side and the right side of the player. And I'm going to say that's this.playerWidth times 0.6f, which is just a value I got based on messing around with things. Then we're going to say raycast begin.sub inner player width over 2.0f 0.0. So we're basically going to move the raycast start to the left side of the player, the bottom part of the left, or actually the center part of the left side of the player. And we'll visualize all this too. I'm going to do some drawing just so that we can see what's happening. And then what we're going to do is we're going to say float y value, or y val is the player state, which we don't have yet. So we'll create that in a minute, equals player state small. So if we're small, we have to raycast a smaller portion than if we're big. And we'll add in player state in just a second. That's going to be minus 0.14f. Otherwise, if we're big, it's going to be minus 0.24f. Since we have to raycast a little bit farther down. Let's go ahead and create that player state very quickly just so that we have that. So up here, our player is basically going to have like 3 states or 4 states. So we'll say enum player state is small. So when we have small Mario, big Mario, fire Mario, and invincible Mario. And I guess you could technically add in one for dead Mario, but that's just Boolean that we have that keeps track of that. I guess maybe it would be better in here, but I really don't care. And then we're going to go up to here, and we're just going to say, before all of these things, we'll say private player state equals player state dot small. So we'll start Mario off as small Mario. Now, once again, this y value is basically just how far do we have to shoot down to get the appropriate thing. And if we're big Mario, we have to shoot a little bit farther down than if we're small Mario. So then we'll say vector 2f raycast end. So where is the raycast endpoint? Equals a new vector 2f raycast begin dot add 0 y val, right? So we're just going down a certain amount of units, whatever our world units are. And then we'll say raycast info equals window dot get physics dot raycast, and we're going to give it our game object. Since we are requesting it, we're going to send it our game object so that if it hits us, we don't count that because we don't want to count hitting ourselves. Raycast begin, and then if we look at the parameters, raycast end is 0.2, and I guess we should call that begin end. It makes a little bit more sense, but it should be fine. Okay, so then we have our raycast info, and before we do anything with it, let's just go ahead and draw it so we can see exactly what's happening. So if we go ahead and say debug draw to add line 2D, and we're going to draw from raycast begin to raycast end, and we're going to give it a color of red just so that we know exactly which line it is. And then I'm just going to go ahead and import these. All right, so now if we go ahead and we just call check on ground inside of our update function, I'll do that right here because we're going to be doing it about here anyways. So I'll just say check on ground, and that should draw the raycast for us. So if we go ahead and run our game, you'll see we get this little red raycast. And you may or may not be able to see this very well because of YouTube compression, but you can see it's on the left of Mario. This is the raycast begin, this point up here. And this point down here is raycast end, and it's just barely touching the ground, which is how I wanted it. I want it to just barely hit the bottom of Mario so that we don't count him as on ground, since we have variable length jump if he's not actually on the ground. So this should do a good job, and you can see it's just barely over on his left foot, so we should get most of his body, no matter what part of him is actually on the ground. Now we want to do the same thing for the right side of him, right? This will tell us if the left side of Mario is on the ground, but we also want to check the right side because he could be like standing on the edge of a block on the right side, and we need to be able to tell that too. So we'll say vector2f, raycast to begin equals a new vector2f, raycast begin dot add inner player width 0. So we're just going to move them over to the right, the width of the player, right? And we can say vector2f raycast to end equals new vector2f raycast begin dot add inner player width 0.0. And that shouldn't be raycast begin, that should be raycast end. Okay, there we go. Then we can get raycast info for that one as well. So we'll say info2 equals basically the same exact thing here, except we're going to be using raycast 2, and that should give us the information there as well. With both of those raycasts, we can tell if we're on the ground by saying on ground equals info.hit. So did we hit something? And info.hit object is not null, so we actually have a hit object. And info.hit object .get component ground.class does not equal null. So we've hit something, it has a hit object, and it also has a ground component. So either that or the same exact thing, except with info2, right? We want to check if the left side or the right side hit anything, and if either of them did, then that is a successful hit, and we are in fact on the ground. And I think right there, we should be good. Okay, so this should tell us whether Mario is on the ground or not. And then if we want to, we can just go ahead and draw that right line as well, just so that you guys can see where exactly that is coming from. So if I go ahead and add that in, and we run this one more time, you can see we've got two red lines on the right side and the left side of Mario respectively. Cool, so that should give us information about whether we're hitting anything. And we're not using this result right now, but it will tell us all the stuff that we're looking for, which is cool. Our physics engine is working, and it's very simple to use, which is how I like it. So let's actually use this information and build a jump for Mario, right? Let's let him be able to create a variable length jump, or the player, I guess, in this case. So we'll say up here, if right after we check if we're on the ground, key listener dot is key pressed GLF W key space. So if they're pressing the space key and the jump time is greater than 0, so that means that they still, since it's a variable length jump, we want to check and see if they've exceeded the maximum amount of time they can hold the space key, which is what that jump time is for. We'll say, or we're on the ground, and I'm going to move this to a new line just so that we can see all this, and GLF or key listener that is key press GLF W key space. So if they're pressing space key and we have jump time left, or if they're on the ground and we have and they're pressing space key, or if the ground debounce is greater than 0, and key listener dot is key pressed GLF W key space, right? So if any of these things are true, then we basically want to check this, and we could probably simplify this a little bit more, right? Because we're checking if the key is pressed in all of these cases. So we could probably just change this to if space key is pressed, and then we can say jump time is greater than 0, or we're on the ground. So I'll remove that, or ground debounce is greater than 0. And that should be the equivalent logical expression, I believe. So we'll copy this, and then we should be able to just say or there. So, okay, there we go. So if they're pressing the space key and either the jump time is greater than 0, or they're on the ground, or ground debounce is greater than 0, then we want to go into this space here. And then what we'll say is if we are on the ground, or ground debounce is greater than 0, and jump time equals 0. So basically they've just pressed the jump key they are on the ground, and we're basically just checking that. Okay, so they just press the jump key. We'll say play the sound. So we'll say get sound assets /sounds /jump small.ogg.play. So we'll play the jump sound since we just pressed the space key. Then we'll say jump time equals 28, which is a good value that I found for a variable length jump. And we'll say this .velocity.y equals jump impulse. Okay, and this is how we're going to simulate the impulse. We're basically just going to say instantly change the velocity, which is sort of what an impulse is. And this will make it so that we jump pretty fast at the beginning. And then we'll start using the acceleration again, which should mean we're going to use sort of a linear jump speed. You'll see. Okay, and we'll say else if jump time is greater than 0. So we still have some jump time left, and they are pressing the space key, right? We already know they're pressing the space key because we checked it up here. And then we'll say jump time minus, so every frame we take one away. This .velocity.y equals jump time over 2.2f, which was just a number I found that worked good, times jump boost, okay? So we're basically saying here, take the jump time. Initially, I had it as jump time times jump boost. So basically, we're just taking it as a factor of the jump time. So we start off at 28, and as time goes on, the player gets higher and higher, right? So the player starts off down here, we have the highest speed. Then the player gets up here, and their speed is lower because we use 27 times whatever the jump boost is. And so it just linearly slows them down, but still gives them enough up force, which gives us sort of a quadratic type of curve, okay? If none of that makes sense, don't worry. It didn't really make sense to me either. I just sort of copied what they did in the original Mario clone, okay? And they'll say otherwise, if the jump time is not greater than 0 and they're not on the ground, then we'll just say this .velocity.y equals 0. So if they're still holding the jump key and they don't have anything left, we're just gonna ignore it and say, okay, 0 out their velocity, so they start falling again. And then right here, we'll say ground debounce equals 0. So that basically makes sure that if we just started pressing the jump key, right, if we're moving up, we don't want them to be able to press it again. So we're just setting this to 0 so that we don't count that anymore. Basically just resetting that value. Okay, so if they're pressing the space key, we've got that handled. Otherwise, if enemy bounce is greater than 0, we'll handle this a little bit later since we don't actually have enemies yet. So I'll pencil that out for now, and then we'll deal with that once we have a chance to. We'll say here though, else if we are not on the ground. So if we're not on the ground and we're not pressing the jump key, we'll say if this .jump time is greater than 0. So if we're in the middle of a jump, then we'll just say this .velocity.y times equals 0.35f. So basically this just makes sure that, and then I'll say this .jump time equals 0. If you release the space key a little bit early, I'm just gonna slow down the vertical velocity and then set the jump time to 0 so that you start falling, but it's not like an immediate huge impulse when you start falling, right? This sort of slows it down gracefully. And I got all these values just by tweaking and messing with things until I got something that I liked. And we'll say here ground debounce minus equals dt. So basically, if we're not on the ground and we just want to subtract dt from the ground debounce. That way, if they still have some ground debounce left, they can still jump, right? So if they just ran off the edge of a block, this will start decrementing since we're not on the ground anymore. And then we can still jump even though we're not technically standing on ground until it goes below 0, then they can't. Then we'll say this .acceleration.y equals window.getPhysics.getGravity.y times 0.7f, which you'll see is right here. So this will basically say, okay, only apply gravity if we're actually falling, right? We're not on the ground, so we're falling, so then we'll apply gravity. This way, we don't like hit the ground and we'll be able to glide over the ground a little bit easier. Otherwise, if none of this is true, so if we are on the ground, right? Because we basically just checked if they're pressing the space key and some other stuff. So that's the first one. Then we're saying otherwise if we're not on the ground. This is saying otherwise if we are on the ground. This is the only possible case we have left. Then we'll say this .velocity.y equals 0. This .acceleration.y equals 0. Ground debounce equals ground debounce times. Since we are on the ground, we'll keep resetting the ground debounce. That way, if they run off a block, then we start taking values away from that, but it's like they have 0.1 seconds left to do whatever they need to do. Okay, and then we get all this. We'll add in one more state machine trigger too. We'll say if we're not on the ground, then state machine.trigger jump. So if we start falling, we just go into the jump state, or if we jump, we go into the jump state no matter what. If we're not on the ground, we go into jump state. Pretty self-explanatory. Otherwise, we'll say state machine.trigger stop jumping. Okay, so jump or we're not jumping. There is no in between for that. So then we will go ahead and run this and see what happens. So if I hit space, you'll see I get this variable length jump. So I can jump small or I can jump high. And it's a little bit laggy, but you can see that I can control the length of the jump. And not only that, but it also gives me a nice smooth arc, right? It's fast at the bottom and then it slows down as I get towards the top. And then when we hit the top, we don't just start falling instantly. It's kind of like a graceful slowdown and then speed back up since we're using acceleration and everything, okay? We can check out if the other feature is working too. So if I drop one of these guys in, and we should actually be able to jump 4 blocks up. So if I put this, yeah, I believe this is the highest we should be able to jump, right? Yeah, that looks about right. Maybe we can jump 1 more block. I'll try that. Oh, and you'll notice there was a problem there. If we hit the bottom of a block, we're still going up. So I'll put that up there, see if we can jump. Okay, so it looks like we can jump up to this block. I'm not sure if that's how I have it in the original, but you'll notice some problems, right? For instance, if I hit that block, I kind of keep my forward velocity. It's not canceling out my velocity, and you'll see I got stuck there for a second. If I hit the top of the block, you'll see I kind of float there for a second. That's something we need to stop too. So these are a couple of problems that we'll fix now. Let's go ahead and actually do that. So how can we check if we're hitting the bottom of the block or the top of the block or any of that stuff? We can use our collision events, right? I'm going to comment those out for now because we don't really need those anymore. So we'll say override public void begin collision, which takes in a game object, colliding object, takes in a contact, and it takes in a vector 2f contact normal. Okay, so first of all, if we're dead, we don't care. We'll return. We don't need to do anything if we're dead. We don't really care about anything, so I'm just gonna put that in there so we have it. And we'll say if colliding object.get component ground.class does not equal null. So if we hit something that is of the type ground, we're gonna check which direction we hit it. We'll say if math.absolute value of x or contact normal dot x is greater than 0.8f. So what am I doing here? I'm saying, did we hit it horizontally, right? If it's greater than 0.8f, I can say with a pretty high certainty that we hit it horizontally because we're trying to correct it left and right, not up and down. Then we can say this dot velocity.x equals 0. So this should take care of us hitting it to the left and right, right? If I run into this block, you'll see I lost all my forward velocity. I just sort of fell. I didn't keep going to the left and to the right, and we still got a bug there, which I'll see if we can fix. But yeah, it just stops us in our track, and we can do this a little bit more too, right? If I put a block here and then I go and run into it, it instantly stops me. I can start speeding up immediately again. If I take this away and we run into this block again, you'll see that it's hard for me to turn around. Okay, so that's why this is important. Now we'll say else if contact normal dot y is greater than 0.8f. So what are we checking here? We're saying otherwise if we're hitting the top of Mario. So in other words, if we're hitting the bottom of a block with Mario's head, right? That's why we're not taking the absolute value here. Then we'll say this dot velocity dot y equals 0. This dot acceleration dot y equals 0. This dot jump time equals 0. So we'll basically zero out all of our vertical velocity so that we just fall back down. So now if I hit this, I just fall back down. Even if I hold space, I can't keep going up because we've hit the bottom of the block. So that's another good thing that we needed, and it just sort of works, which is nice. Let's also go ahead and real quickly, because this is bothering me, when we hit the bottom of this block, it should bob up and down, right? Because that's how Mario works. So let's go ahead and implement that really quickly. So let's go into breakable brick, which I thought we created. Maybe we didn't. I said we would do that in this episode, which we will. So let's go into level editor scene initializer where we have this right here. So we'll say object.add component new breakable brick, which is just a brick that we can break, right? Self-explanatory, hopefully. And then we'll say this is breakable brick, and we're gonna say that this extends component. And we should be able to just say at override. Actually, okay, yeah, so I did this a little bit differently. Since we have a couple different kinds of blocks that can be hit from the bottom, like a coin block or a breakable brick, I had these inherit from a common ancestor, which I don't usually do, but it seemed appropriate in this case. So I created another component and we'll call this block, okay? And this one is gonna have an abstract method that we can use. This will expend component, and this will sort of be the base for any sort of block that moves up and down when Mario hits it, or can break or do whatever, right? So we'll say private transient Boolean bop going up, okay? So I literally just called it bop because that's what makes sense to me. Private transient Boolean do bop animation, right? So are we gonna do the animation? That's false initially because he hasn't hit it yet. We'll say private transient vector 2f bop start. So where did we start this? And we'll just initialize that to nothing. Private transient vector 2f, we'll say top bop location. So where do we stop going up? And then private transient Boolean active equals true. So can we still go up and down, or can we no longer go up and down? And then lastly, I added in a variable that can be tweaked if you want to, called bop speed. And I think I just set this to 0.4 f, and that should be good. Then we'll say at override public void start. So on start, we'll get the start position in the top bop location. So we'll say this dot bop start. Oh, and I called that bob. That should be bop. Equals new vector 2f. This dot game object dot transform dot position. This dot top bop location equals new vector 2f bop start dot add 0.0f 0.02f, which was a good distance for me. You can tweak all these values if you want. Next, we're going to override the update method. So say public void update float delta time. We'll say if do bop animation. So if we want to do the animation, we want to go up and then we want to go down, right? When Mario hits the block, it just goes up, then it goes down. That's all we got to do. We'll say if bop going up. So if we're going up, if this dot game object dot transform dot position dot y is less than the top bop location dot y, then we're going to keep going up. We'll say this dot game object dot transform dot position dot y plus equals bop speed times dt. Otherwise, bop going up equals false, right? So if we hit the top of the location, then we'll start going down. And then if we're not going up, then we must be going down, right? So then we'll say if this dot game object dot transform dot position dot y is greater than bop start y, so we still need to go y, or still need to go down. We'll say this dot game object dot transform dot position dot y minus equals bop speed times dt. And then we'll say else this dot game object dot transform dot position dot y equals this dot bop start dot y. So this is kind of important. It's something I've just picked up from doing games. If you ever have something that's supposed to result in ending in its initial location, you should always just reset the value, because floating point errors will make us that slightly off. And if it keeps getting slightly off every time, then your game object will eventually veer off quite a bit. So we just reset the value here if we're done doing the animation. We'll say bop going up equals true. So we reset it so that it can do it again if it needs to. We'll say do bop animation equals false. So we say stop doing the animation. Then down here, we'll say at override public void begin collision game object obj contact vector 2f contact normal. So just the normal collision stuff. Import this. Say player controller equals object.get component player controller dot class. And then we'll say if we're active and player controller is not null, so we actually got a player controller on that, and the contact normal dot y is less than negative 0.8f. So that should be contact normal. We're checking, first of all, can we do the bop animation? If we can, then we will. Did the player hit us? If a player hit us, then we need to do the animation. But only if the player hit the bottom of our block, which we can check by just seeing if this is less than a certain threshold, which minus 0.8f was good for me. We'll say do bop animation is true if this is all true. And we'll say asset pool dot get sound assets slash sounds slash bump dot ogg dot play. And then we will say player hit, and we'll give it the player controller. Then we're going to give this an abstract void player hit, and this will take in a player controller, the player controller, right? So this is an abstract method that we can call What's wrong here? This is a non-abstract class. No, this is an abstract class. So let's make this abstract. You can't instantiate this. We just call this method, which gets implemented by whoever inherits from us. And then we'll have this public void set inactive function, which basically just sets us to not active. So this would be for like question blocks where you can hit it once, but you can't keep hitting it after that. So perfect for those. And then we can go into here, instead of this inheriting from component, we'll inherit from block, and then we will implement this player hit method. And then we'll basically just say up here, if player controller.is small, which we'll implement in just a second, asset pool dot get sound assets slash sounds slash bump dot ogg dot play. So if they're small, we'll just play the bump sound, which I don't think we even have to do because, yeah, we play it in here. So if it's small, we don't really have to do anything. So I guess we could just change this to if it's not small and say we basically want to break it in that case. So we'll say get play sound assets slash sounds slash break block dot ogg dot play. And then we'll say game object dot destroy. So we'll destroy our game object and we will play the sound. And I guess we maybe don't want to play the sound in here because it'll play regardless. We'll think about that. You can change that right now if you want to, because that's probably the better thing to do, where we don't play it inside the parent class and only subclasses can play it if they want to, because that's probably the best thing to do. Inside player controller though, let's just say public boolean is small. We'll return this dot player state equals player state dot small. All right. And then if we play this, we should be able to hit the bottom of this block. If I can hit it. Okay, and it's not doing anything. Why not? Because we just changed the prefab, but we haven't actually updated this. So now if we go ahead and put that in again, we should be good. There we go. Okay. It's vibrating. Looks like I probably messed something up because this isn't going quite right. So let's go ahead and look through this again. Oh, and it looks like I just placed this else clause in the wrong block. So that should be right down there. And if we go ahead and do this one more time, let's see if this works now. So if we go ahead and hit this, still not quite right. Let's see what else we got wrong. And you know what I think it is? I think it's if we go into rigid body, this one, there was one thing that I implemented that I completely forgot about. So if we scroll up to the top, we basically say we're going to set the position regardless of whether we have a dynamic body or a static body according to Box 2D's physics, right? Where actually what we want to do is we want to say if this dot body type is body type dot dynamic, or this dot body type is body type dot kinematic. If we have either of those, then we want to do this where we sort of tell our game object, hey, just align yourself with the physics engine. We want to use whatever the physics engine says we should use. And actually what we want to do in this case too is we'll even say vec2 vel equals raw body dot get linear velocity. And we'll even say this dot velocity dot set vel dot x vel dot y. That way we set ourselves to the physics velocity too, and we could do the same thing for all our values. That could be changing while physics is running. Otherwise, if we have this dot body dot type equals body type dot static, which means the body should never be moving, then we want to say this dot raw body dot set transform to a new vec2, this dot game object dot transform dot position dot x, this dot game object dot transform dot position dot y, comma angle 0.0f, which we could technically use the game object's angle to, which is probably a better value anyway. So I'll change that to this dot game object dot transform dot rotation. All right, and that is a much better value to set. So we basically say, hey, physics engine, set this to what I want to set it to. So if we implement these changes and run this one more time, then we should see, yeah, okay, so the block goes up, then it goes down, okay? And it does it the correct way. What was happening before was basically we were trying to set it up, but then the physics engine was saying, no, this block is actually down here. And then it was just sort of jittering because it was trying to go back and forth between two positions because the physics engine and my engine were fighting based on what position it should be. So we basically tell the physics engine, hey, if we are using a static body, we control the position. Otherwise, you control the position of the object, and we'll just sort of let you do that. Okay, so that's why that worked. I guess since we're going along this route too, instead of doing enemy AI today, we'll just do the question block, right? So one of the blocks we have in Mario is a question block, which can put out a power up or a coin, depending on whatever you want. So we'll actually have this, right? We already have it so that we can generate it, and we have the animation, which I called run. Let's just change that to flicker, since that is what the question block is actually doing. So I'll just change all of that. Should be good there. And then we actually want to add one more animation state too. We'll say animation state inactive equals new animation state. So when the button is done, and then this is just gonna be, first of all, the title is inactive, and then we can say inactive.add frame player sprites, which is actually the item sprites in this case, get sprite 3 0.1f, this, or inactive dot set loop false. So we don't want this to be a looping animation. And then we can go ahead and just say right here we have the state machine. We'll add the state to inactive. We can say state machine dot add state. So we'll add a transfer here, flicker dot title. So we'll go from flicker to inactive on set inactive. Okay, so that's the trigger, and that should all work out properly. Okay, and then we'll go ahead and we'll also say question block to add component new question block, which we will create in just a second. And then we'll go ahead and say rigid body RB equals a new rigid body, RB.set body type to body type dot static. Then we'll say question block dot add component RB. Then we will say box 2D collider, B2D equals new box 2D collider, B2D.set half size to new vector 2f, 0.205f, 0.25f. So we set the size of those. And then we'll say question block.add component B2D. And then we'll also say question block.add component new ground, because it can also act as a ground component. And then we just return the question block as normal. Let's go ahead, we'll create a new component in here. We'll call this question block. And now we can use that fancy parent component we just created, right? We can just say this extends the block class. And if you were using a functional language or something, you can accomplish this exact same thing using functions, okay? I don't think inheritance is special at all in this way. I would use a completely different technique in C++, for instance, than inheritance, because I think it's overkill for this, honestly. Okay, but anyways, with that aside, let's go ahead and implement this. So we're going to go ahead and we're going to say private enum block type, and this is going to have a coin, so we can have a coin block, a power up, or invincibility, which I don't think I ever had an invincibility, but it's there, and I'll leave that up to you guys to implement. So we'll say public block type, block type equals block type dot coin. So we'll just have these as coin blocks initially, and then let's go ahead, we'll implement this method. And I'm just gonna put this below all that stuff. So we'll have player hit, and we'll say switch on the block type. If we have a coin block, then we'll say do coin player controller break. Otherwise, if we have a power up, we'll say do power up player controller break. Otherwise, if we have invincibility, do invincibility player controller break. And then after we do whatever we do, we just want to say state machine equals GameObject.getComponent state machine.class, and we'll say if state machine does not equal null, then we'll just trigger set inactive, and then we'll say this dot set inactive. Okay, so we trigger it, and then we also set it in the block type so that we can't bop it up and down anymore, because we are extending from the block class, right? Okay, then we just need these functions. So I think if I hit Alt Enter, we can say create method. Just hit escape, that should be fine. I'll do the same thing for this one. Hit Alt Enter, hit create method, that should be fine. Same thing here, create method, we should be good. Okay, cool. So then if we go ahead and go into do the coin, so we want to do coin, we'll say game object coin equals prefabs dot generate coin, or block coin, since there's coins and then there's coins that come from blocks, and We'll go ahead and implement this as well in just a minute. For now, it's not there. We'll say coin.transform.position.set. This .gameObject.transform.position. So it basically starts from inside the block. Well, not quite inside. We'll say position.y plus equals 0.25f. So we'll have it start to like one block above this block. And then we get the scene and we say add GameObject to scene coin. Okay. So once we actually get this implemented, it should all work great. For now though, if we just go ahead and add a question block, we should be able to hit it and it should go to the inactive state. So if I go prefabs, add in a question block here, we click onto it and you should be able to see we have a coin block here and we can change that in the future and now if you want to. And if we hit it, it turns into that block and we can no longer bump it. We can bump this one multiple times though. Okay, so that's sort of the first step. Now let's go ahead and implement this coin block real quickly. So we'll uncomment all that and then we'll go into prefabs and then we'll go ahead and we'll say public static void GameObject generate block coin, and we need the items. I'm just going to copy this because we're going to have a lot of the same stuff. So go ahead and copy that. And then I'm actually going to call this items because that is what this is. And this is a coin. This is not a question block. And we'll say this is going to use items.getSprite7. We want it to be the same size. We'll have an animation state coin flip, and we will call this coin flip. So we'll change the title up here as well. Then we just want to add items here. We want to add in 7, 8, and 9. We do want this to loop. We don't want a second animation, so we can remove that. We can remove that. Then we'll just add the flip here, add it here. We do not need any triggers since we just have one thing. And then we can go ahead and say add it to the coin. And I will do all this stuff as well. And we don't even need a hitbox or anything on this since it does not really do any of that stuff, right? So we'll just say coin.add component new block coin, which we'll add in just a second. Oh, and I said public static void GameObject. Remove the void there if you copied me. Okay, that should just be public static GameObject. All right. And then let's go into here. We will add a new component block coin. We'll say that this extends component. All right, and then we'll say private vector 2f top y private float coin speed equals 1.4f. Once again, these are just values that I found that were good. And then we'll say override public void start. Then we'll say top y equals new vector 2f this dot GameObject dot transform dot position dot y dot add 0.5f. So this is how far I want it to fly up whenever you hit it. And we'll say asset pool dot get sound assets slash sounds slash coin dot ogg dot play. So basically whenever it gets instantiated into the game world, it'll play the coin sound. This is why it's different than a regular coin, because you wouldn't want it playing coin sounds every time you just drop a regular coin in the world. Then we'll say override public void update float delta time. We'll say if this dot GameObject dot transform dot position dot y is less than top y dot y, and this is where it's different too than a regular coin. We don't have to wonder if it's doing the animation, because as soon as it gets instantiated, we know it's going to do the flying up animation. So we'll say this dot GameObject dot transform dot position dot y plus equals dt times coin speed, and we'll say this dot GameObject dot transform dot scale dot x minus equals 0.5f dt times dt modulus negative 1.0f. So this is basically going to make it so that looks like the coin is flipping as it goes up, as we just change its scale. We'll say otherwise, if we've reached the top, then we'll just destroy this game object, and you could count it towards the player and all that stuff too if you wanted to. Now if we play this, we should be able to say generate block coin, and then we should be able to play this. And if we go ahead and hit this, you'll notice we get the coin, right? We hit it and we get a little coin, and we can't hit it again because it won't let us, but we could duplicate this. Well, I guess we can't duplicate. Something went wrong there. I think it did duplicate. It's just not showing up, right? Yeah, if we play it, we see it there. We can fix that pretty easily too, and we probably will in just a minute. So you see we can get coins, right? That's pretty cool. We'll add the power up and everything in the next episode because this one has been going on for too long. But I hope you guys enjoyed this. If you did, please hit like and subscribe. And in the next episode, we'll be adding power-ups and enemies. All right. So basically you can hit this, pop out a mushroom or a flower, and we will have Goombas, not quite the turtles yet. I think we should be good just implementing those two features in the next episode. I'll see you guys then. Thanks for watching.